Okay, so here's the next problem. Let f be a differentiable function such that the integral of f of x sine x equals minus f of x cosine x plus 4x cubed cosine x. Which of the following could be f of x? Okay, so we have the integral, right to the tripod here, it's going to be tricky. F of x sine x equals minus f of x cosine x plus the integral of 4x cubed cosine x. And it says which of the following could be f of x. Okay?
Alright.
And you left this one blank.
Mm-hmm.
Alright? What do you think? Why did you leave blank, first of all?
Well, I wasn't even sure how to approach it.
Okay. Alright, so today, with the day of thought, do you have any guess what you might want to do here?
Well, I think taking the derivative of both sides is probably a good place to start.
Yeah, that's right. What's the derivative of this integral?
That's just the inside f of x sine x.
Okay. F of x sine x. What's the derivative of this expression?
That's minus f prime of x cosine x plus, I guess, minus f of x. F of x is minus I, so yeah, it's gonna be a plus f of x x. And then we're gonna add on 4x cubed cosine x.
Okay. How does this simplify?
Well, we can just subtract this away from both sides, and then we can move this to the other side and take out a cosine.
Sorry, I put my papers on top of the eraser so I couldn't find it. Okay, so I end up with 4x cubed cosine x equals f prime of x cosine x.
So we know that f prime of x is 4x cubed, so we know f of x is x to the 4th. That's a constant. I don't think any of the choices had constants.
And they sure didn't.
So x to the 4th is the choice.
And since minus x to the 4th is a choice, it's actually worth just double checking, you know, the sign, the sign if you have time. But yeah, that's exactly how you approach this problem. This is a fundamental theorem of calculus problem. This is also related to a technique of integration called integration by parts. Well, there you go. Okay, so that's the first 4 non-calculator ones. And now we'll move to the calculator ones.
Alright.